The transposition of sets is an extremely important process within music, both in tonal and post-tonal music. Transposition is the process by which each element in a set is moved by a constant interval. For example, the point 2-1, when transposed by two semitones, would become 4-3. Because each element of the set is moving by a constant, A, then the collection of all possible transpositions would be the line whose slope is 1 and contains the initial point. In T-space, each of these lines would be collapsed into a single point, which now represents all possible transpositions of the original set. Starting with a two-dimensional plane, the resulting T-space would be a line, where each point on that line would represent the distance between the two pitches. Therefore, each point in the space could be thought of as representing an interval. OT space would involve the same process, simply occurring on the surface of a torus. If we imagine the torus being sliced open and straightened out, then the ends can be rotated to align the lines of transposition and then mapped onto each other, like flattening a soda can. The resulting space is a circle containing all possible intervals smaller than an octave. Two-dimensional PT space would appear as a ray extending from the origin along the x-axis in a single direction. If we start with OP space, we can model OPT space by marking the lines of transposition on it. Then we can untwist the space, aligning the lines of transposition, and then collapse the space. This model is indistinguishable from OT space. This is because P equivalence does not change the size of the interval. Without the concept of transposition, there would be no method to equate intervals. Melodically, we would not be able to discuss things such as sequences or motives that occur in different keys. It also affects harmony as well, in that chord classes would no longer exist. A C major triad would no longer be equal to an F major triad.